All right, here we go. So we're doing quadratics again. This whole chapter has been quadratics, but this time, what's different about this one compared to what we've done before? It's inequalities. So what's the difference between an inequality compared to what we've been doing? What kind of signs are we going to use? Not the alligator. It's less than, greater than. It could be less than or equal to, and it could be greater than or equal to. All right, so these are the signs that we're going to be using now, okay? This is a little different. It's kind of the same. All right, there are some things that are the same, but there's things that are different. Do I want to say that first part? Let me see. Yeah, let's do this. Watch. This is what I wrote down at first. I don't know if it's that super important that we even write this down. I think you kind of know this already instinctively, but I'm going to do it anyway. I think it's in the book. So if PQ is greater than 0, now PQ, it means P times Q. It just means any number, excuse me, any real numbers, P times Q. If your answer is greater than 0, so tell me something about P and Q. No, I'm sorry. Tell me something about the signs of P and Q. There you go. Okay, they could either be both positive or both negative, which means they have the same what? Same signs. Good. Again, you kind of know that already. And then if PQ is, what do you think? Less than 0, which means it would be what kind of a number? A negative number. Then tell me something about the signs of either P or Q. Be different signs, correct? Okay, one's positive, one's negative, or we'll just make it easy and just say that they have different signs. Okay, the P could be positive. If the P's positive, the Q's got to be negative. If the P was negative, then the Q has to be positive. Different signs. Everybody go with that? All right. So let's go right into an example and just show you how to do these things. This is a quadratic, and you are solving, but with inequalities, you're not just going to get like one answer or two answers or three answers. You're going to get like an infinite, really, technically. On a lot of these, you're going to get, I think all of these, you're going to get an infinite number of answers. I'm going to be complaining about this pen and this marker. I don't know why it's acting so weird, but... Wait, you said this is the longest chapter in the book? I didn't say that. I just said it's a long chapter, but I didn't know if it's the longest or not. It could be. I didn't really do that much research. All right, so here we go. Here's the difference. It used to be they just said equals 0, so that would have been simple, right? You just factor them. If they can factor, set it equal to 0, or set both of them equal to 0, and then you got two answers. Easy. All right, this is a little different, though. But we start off doing it the same exact way. So what are we going to do to start this thing off? We're going to see if these factor, right? There's other ways to do it. Could do quadratic formula, complete the square, all that kind of stuff. All right, but this one does factor, so let's do it like that. So what's going to go in here? X here, X here. What do we got? -2 times, what do you think? These two have to multiply to be -2, and they have to add up to be a -1. What two numbers do that? You got a 2, so you only got 2 and 1 are your options. So what are my signs going to be? So you know you're going to have to use a 2 and a 1, correct? When they multiply together, it's a -2. When they add together, it's a -1. So how do I get those added together to be a -1? The -2, right, that's all I wanted, okay? Is the 2 is going to be negative, and the 1 is going to be positive. Would you agree that works? Yeah, this is factoring, right? We've done a lot of factoring in this chapter. So, that's something you should just be able to just do just like that. All right, now, here's the key. We're going to set... Remember what we did earlier? We said if this is greater than 0, then both of these have to be either what? If these are positive, this is my P and that's my Q. If it's going to be positive, then they're either both positive or they're both negative. So that's how I'm going to write them out. All right, so I'm going to write them both positive first. All right, so that means x minus 2 has to be what? Greater than 0. And the other one, x plus 1, has to be what? Greater than 0. Right? Both positive. Okay, or they can be what? Both negative. That's right. Sorry about my writing. Both negative. So what can we say? We can say x minus 2 could be what? How do I show negative with inequalities? Less than 0. Anybody here today? Come on, I'm not getting much feedback. You thought I was tired? You guys sound way more tired than me. So watch. X minus 2 has got to be negative, and what else? That's a terrible and, but I'll keep it there. X plus 1 could also be negative, right? Because of this stuff right here. Got it? So it says if PQ is greater than 0, there's my P, there's my Q. Is it greater than 0? Yeah. So the same signs, right? They got to have the same signs. So this has to be positive, or this has to be positive, or what? This is negative and this is negative. And that's what we just did right there. Everybody got it? Okay. So what we're going to do is we're actually going to do some solving. To tell you the truth, this is how they taught it in the book. I'll show you maybe a little shortened way. All right. When I took notes on this, I was just going by what the book was doing, okay? And which is fine. It's not a bad thing, but I'll give you a little bit more streamlined, a little bit more simplified way to do this. Is that all right? But let's do it the way the book was doing it. So let's solve for x right here. So what's x going to be right here? I added 2 to both sides, so x could be what? Greater than 2. And x could be what? Greater than what? Negative 1. Subtract 1 from both sides. Negative 1. Or, what do we got here? X is less than positive 2, and x is, well, that's what we're going to do. We're not there yet. Or x is what? Less than, what do we do? Minus 1, negative 1. Agreed? All right, so here's what we're going to do. We're going to actually use a number line for this. I'll tell you what, before we do the number line, see all this mess? I'm going to do this in a different color, just to show you. This is kind of the way again, I don't know why. I think I probably just had the book in front of me, and I was just writing down what the book said, and I guess I wasn't thinking on my own. But here's a little bit easier way to do it. You see this, x minus 2? What I'm going to do is put x, now listen to me. I'm going to put equals, but it doesn't mean it's equal, all right? Because it is greater than, but I'm going to put equal anyway. So x could equal 2, right? X minus 2 equals 0. Or x could what? Equal negative 1. Okay, so now what I'm going to do is draw a number line. Let's make my number line white. This is, I think, the way I'm doing it in yellow is a little more streamlined. It's a little bit easier to visualize what's going on. So this is a number line, so it just keeps on going in both directions. But what I'm going to do is I am going to put on this number line a negative 1 and a 2. That's all I'm going to put. Negative 1, positive 2. Make sure you put them in the right order. Okay, the negative's got to be left of the 2. You with me on this? Now, even though I said equals, it's not really equals, but that's where I'm going to put my important points on my number line. Is that all right? All right, so it's not really equal to 2, but it is what? It's greater than, okay? So what I'm going to do, and it's not greater than or equal, is it? It's just greater than. So what kind of a circle am I going to put here if it's not or equal to? It's an open circle. So I'm going to put an open circle here and an open circle here. Now, why did I use that number line? I'll show you why. Because our answer is going to be in one of these 3 regions. Do you see these regions that I've made? I've got everything to the left of negative 1. I got everything to the right of positive 2, and I got all the stuff in the middle. Okay? So what I'm going to do is this. I want to see which numbers satisfies this inequality. So pick any number to the right of 2. Now, would you pick 347? Of course not. Pick something super easy that's to the right of 2. Just go 1. Let's just go 1 to the right, which is a 3. All right? That's the easiest way to do it. Would you agree? So what I'm going to do, let's write this down again right here, just so I don't have to keep looking way up there. So this is what we have. So what I want to do is I want to find all the values that make this greater than 0 or positive, right? I want to find all the values that make it positive. I don't even actually have to find the exact value, okay, when I put a 3 in for this. All I care about is if it's positive or negative. So let's do that. Let's put a 3 in for this. Let's just do it in our head. 3 minus 2, what's 3 minus 2? It's 1 and it's positive, correct? Put a 3 in for this. 3 plus 1 is 4, but it's a positive, correct? What's a positive times a positive? So any number you pick, it does not matter. Any number you pick to the right of 2 is always going to be what? Positive. Does that satisfy this inequality? Yes. Any numbers, okay, I could pick, remember what I said earlier that you could get an infinite number of answers? Technically, that's an infinite number of answers. I could pick 2, 3, 4, 5, 100, 1,000, 1,000,000, 2 billion, okay? And that will satisfy this inequality, okay? Let's pick a number between -1 and 2. What's an easy number between -1 and 2? Easier than that, 0, okay? You could pick a 1, perfectly fine, all right? But let's just pick 0. I think that's a good choice. So 0's in here somewhere, isn't it? Put a 0 in for this. So 0 minus 2 comes out to be what? A negative, correct? Again, I don't even care what the number is. I just care what the sign is. Let's put a 0 in for this. 0 plus 1 is going to be what kind of a number? Positive. So what's a negative times a positive? That's a negative. Okay? So this region, any number that I pick that lies between -1 and 2 is going to give me a negative answer. Any number I pick to the right of 2 is going to give me a positive answer. Okay? What if I pick a number to the left of -1? Pick a super easy number that's to the -2s. Perfect. So let's put that again into our little inequality right there. So -2. So -2 minus 2 is negative, correct? Again, I don't even care what the number is. I just care if it's negative or positive. Put a -2 in for this. What's a negative plus 1? -2 plus 1. What's that? It's a negative. Agreed? What's a negative times a negative? It's a positive. So that means any number that I choose to the left of -1 is going to give me a positive answer. You could have picked -3, -10, -1 billion. Okay? It's always going to give you a what? A positive number. Does that satisfy this inequality? It does. What are we looking for? We're looking for all the numbers that are what? Positive, right? So where are my positive numbers? Well, to the left of -1, and where else? To the right of +2. There's a couple ways you could write this. I'll write it the way that they do. And by the way, let's do some shading. All right, so if I was to graph this thing, it would look like this, wouldn't it? Shade in all that. What about this? Shade in all, oops, why am I going downhill? There we go. Shade in all of that. So those are all my answers. Okay, wherever the shading is, that's all my possible answers. But how do I write that? Well, you could write it like this. X could be what? Anything where? To the left or less than what? -1. Okay? Or X could be any number where? Greater than +2, and that's your answer. So there's a bunch of answers, but this is how we would write it. Let me show you something that you probably haven't seen before. I don't think we've done this in here, so this might be brand new to you, but it's just the notation. If I keep going all the way to the left, how far can I go? To infinity, correct. But you're going to the left, so we're going to call this what? -infinity. Have you ever seen that before? Okay? What if you go to the right? This would be what? Positive infinity. Agreed? All right? So what we're going to do is this. This is called, I don't know what they actually call it. Just inequality notation, I guess. We'll call it that. Okay? Come on, pen. Inequality. I think I'm writing too fast. I might have to change a setting. Inequality notation. We'll call it that. This next one is called, if I can remember, wasn't really planning on doing this, but I started thinking about it. What do they call it? Interval notation. Interval. I'll just put that right here. Notation. So I'm going to show you. Actually, I need to see the graph. There we go. So watch this. This is probably brand new to you, but the higher up you get into math, the less and less you're going to see this inequality notation. Everybody hearing me? Yeah. All right, got heads down. Not a good time for that. So this right here is inequality notation, but even in high school, in Algebra 2, all right, they're going to get away from this kind of less than, greater than. This is what they're going to do. They're going to say, what numbers are possible here? Anything from negative infinity all the way up to where? To -1. So this is what they do. They use a bracket to mean open. So this means open. And they use, I'm sorry, not a bracket, a parentheses. They use a bracket to mean closed. So if it's an open circle, that would be a what? Parentheses. If it was closed circle, it would be a bracket. Everybody with me? Now, infinity. Can you ever get to infinity? No. So do you think that's open or do you think that's closed? It's open because you can never get there. All right? So watch what I'm going to do. I'm going to go open from negative infinity, then a comma, all the way up to where? Where do we stop? To -1. Is -1 open or closed? It is?
No, it's open.
Is that closed? It doesn't include -1, so it's open. So we put a parentheses. Then we do this. This is kind of weird. You probably learned this a long time ago when you were a kid. Did you learn like intersection and union and stuff like that? Okay, that's what we're going to do right here. Don't worry about it. We're only going to do one of those things. So you put, oops, come on, pen, help me out. Put a big old U right there for union. This is how you write it. Now, what do you think the other part is? I bet you can do the other part. From where? Where does it start? So I'm going from left to right. I'm going from negative infinity to -1. Then I'm not going to include any of this stuff. Then I start where else? At 2. So what kind of a parentheses? 2, comma, infinity, parentheses. So that's another way to write it. That's called interval notation. I think the book right now is using this inequality notation. All right, but eventually they're going to be using this. So since I taught you this, you could use either one, whatever one you like better. Did you learn it last year? Good. And we did that in geometry? We did? I taught you geometry, didn't I? And I taught you this stuff? Oh, good. I don't remember teaching that in geometry, but maybe I did. All right, let's do another one. Running out of time. That's okay. I can, because tomorrow I just gave you time to do work. Okay, so these are all kind of the same. They just have slight variations to each other. All right, let's do this. I got 6 minutes, about 5 minutes. So example 2. Let's do this in white. What's easier to read, the white? Doesn't make any difference. Yeah, black wouldn't be too easy to read. Okay, so 2x squared minus 2 less than or equal. Okay, we got a less than or equal now. 1 minus 5x. Here's what we're going to do. Okay, we want to make this as to look like a quadratic. So we want everything to be on the left-hand side, then a 0 on the right-hand side. So we should be able to do that. That's nothing new. So the 2x squared stays there. Let's move the x over. That gives us a plus 5x. Let's move the 1 over, so we subtract a 1. So I got negative 2 minus 1. It's going to give me negative 3. So that step shouldn't be a big deal, should it? So now what we're going to do is we're going to factor this. A couple ways you could factor it. I'm just going to give it to you since we're running out of time. All right. You can do like a little guess and check. You could do that thing where you go 2 times -3 is -6, and then do that grouping thing. You could go through all that stuff. I'm just going to give it to you. If this thing will cooperate. And then, oh, I put equals. Why did I put equals? That was dumb. Somebody stop me. What should this be? Less than or equal. Okay. And then what else? X plus 3. Would you agree that works? 2x times x is 2x squared. Then I got a plus 6x minus 1x is a plus 5x. And then that's a minus 3. Yep, it works, doesn't it? All right. I just didn't go through all the steps, but that's what it is. So now what are we going to do? We're going to take both of these. Now this time I am going to put it equal. Technically, it's not equal to 0. Well, it could be equal to 0 because it's less than or equal to 0. So this time we could put equals 0. All right. Let's do the other one. X plus 3. I'm just trying to find those places on the graph that are important to me. So let's solve for x. Add a 1, divide by 2. So x is 1 over 2. Right here is just subtract a 3. So that's easy. X equals -3. Let's make that kind of look like an equals -3. It's not my answer. Okay, what am I going to do? Draw a graph, right? So let's draw the graph right here. And let's put those numbers in there. Well, -3 is my smallest number, so I'm going to put it to the left, and then 1/2. If you want, you could put a 1 and a 2, but I'm just going to put a 1/2 right there. What's that?
X equals -3?
Yes, x equals -3. So now what am I going to do? I got to figure out what regions is this going to be less than or equal to 0. Excuse me. So let's put some numbers in. Let's put the 0 in first. Is that all right? Again, I'm going to write this up here, even though it is right next door to us. And I want to figure out, if I put a number in this region, is this going to give me a positive or a negative number? If I put a number in this region or this region, is it going to make it positive or negative? So let's pick one. Let's pick an easy number. What's a number between -3 and 1/2? 0. Let's put a 0. 2 times 0 is 0. Minus 1 is a negative. And then put a 0 in for that. That's a positive. So anything in between here is going to be what? It's going to be negative, isn't it? What do you think the other two are going to be? They're going to be positive, okay? And again, due to time, you could put a 1 in here. 2 times 1 is 2, minus 1 is positive. Put a 1 in there, that's going to be positive. That's positive. Put numbers over here, that's going to be positive as well. So what do we care about? We care about the negatives. Why do we care about the negatives? Because we're trying to find what is what? Less than or equal to 0. So am I just going to put an open circle right there? No, what kind of circle is it going to be? A closed circle. And then what's this going to be? This is also going to be a closed circle. And what's our shading? Everything where? Everything that's negative. So it's just all the stuff in between -3 and 1/2. How do we write our answer? You could write it a couple ways. You could say x is between -3 and 1/2. That would be the, whatever you call this. What did I call this? Just wrote it down. What do I call this thing? The interval notation. Or no, the other one's the interval. What's this one? What did I call this one? The inequality notation, okay? Or you could write it as what? -3. It's closed, right? Because this is closed, comma, where? 1/2. That's also closed. Either one of these, they mean the same exact thing. It's just two different ways of writing it, okay? The interval notation right here is a way that we're going to start writing things. Now, I haven't taught out of this book, but I assume that they're going to start writing things like this when they do inequalities. All right? And that's how you do it. Now, number 3, example 3, is a little tougher, and we've run out of time. We have, right? It's 5 after in this class? Yeah. So we've run out of time, but what I'll do is remind me tomorrow at the beginning of class to do example 3 for you. Or you could try it yourself, okay? Look in the book. That'd be a good thing. You're in honors class. I've given you enough information where you should look at number 3 and be able to do that. It's a little bit more complicated because it's not an easy factoring. You can't just factor it like this. You're going to have to use a quadratic formula. It becomes a little bit ugly, but you should be able to at least attempt that. All right, so 1 to 14 is your homework, okay? So tonight, and I kind of doubt, what's that? Just put it right there. Okay, so 1 to 14 is your homework, and we're going to call it A, 5-9A, 5-9A.